Mechanical Rock, for the past year or so, we have been trying to use serverless for all our new products. It's helped us keep our operational costs down and focus on the application rather than managing servers, because we're not interested in that. But at the same time, we're also passionate about BDD and test-driven design. So we've also been looking at how we can make TDD effective in the serverless world. So a little bit about me. I've been a developer for a while, doing stuff. I blog here, along with the rest of the Mechanical Rock guys. You'll see me around the meetups, DevOps or Agile testing. But the focus for me at the moment is around building cloud-native platforms. So how can we give development teams everything they need to begin deploying stuff to production as fast as possible? So that was a great talk from Matt and Reese about how they're building a cloud-native platform at VGW. And I'm glad to say that hopefully we helped a little bit along the way. And if you're deploying code continuously into production, how can you be confident that that code is supportable and it's secure? So we've been working with the guys at Bank West, and we've been doing behavioral-driven infrastructure. So how can we define the infrastructure and the compliance rules up front to make sure that it's continually compliant as you're deploying new software? And last week, I'm going to throw the shout out now, we helped Bank West deliver their first cloud-native application into production. Woo. So what do I mean about serverless at speed? So in order to be able to develop at speed, you need a fast feedback loop. So I'm going to talk about some of the factors that affect it. I'm going to talk about architecture, so how serverless changes the way that you maybe should approach the problem. I'm going to talk about how you should design your functions themselves to make sure that they're helping promote fast feedback. And I'm also hopefully going to demonstrate how you can develop at speed and be confident that services are going to work, they're going to all hand together before you've even deployed it anywhere. So I've seen this as a development approach. I'm going to make a change, do a deployment, wait a bit more, wait a bit more, poke it in deployed environment. No, that doesn't work. Go around the loop. Now, I like sword fighting as much as anyone else, but we can do better than that. So I've heard complaints that serverless development is slow as painful, or we should just develop in the cloud. Sorry, but my opinion is, if that's you, it's not a problem with tool, or it's not a problem with serverless, it's your fault. Because in order to develop effectively, we need a fast feedback cycle. So if you're developing by deploying stuff into the cloud, turn it upside down, you've got a cupcake. No wonder it's a frustration. So how can we do better? I don't think there's a single solution. So first and foremost, I think it's test first. Because if you test-driven design, it's going to challenge you to focus on that feedback loop. If you test locally, it's going to be faster, no-brainer. But then how do you structure the application and the design to make sure that you can support fast feedback and test first? If it's testable, and it's testable locally, then you're going to get that fast feedback loop. So, wow, that's a sucky color section. So consider the problem of copying messages between two Slack accounts. How would you tackle it? Consider some of the challenges you might have to deal with. So how many messages are there in a single channel? How long will it take? What happens if one of the messages fails to send on the other end? Now, in my mind, serverless sort of challenges you to start thinking in an event-driven approach, because functions and AWS Lambda, they're invoked by an event. Function invocations, you want them to be immutable so that you can maximize scalability. And functions themselves have got a limited lifetime. So you want to avoid long-running processes, and again, that's going to help with durability. So this is my thought of how you might tackle that problem. And by starting with the events, you get a command, I want to migrate a channel between A and B. You're going to read some messages out of your source channel. You're going to publish some events, each one of those migrate message. At some point, you're going to be done. So it's migrated, and then you want to start reading them so you can post them into the destination. So adding a few functions in between. Each function is going to be small, and it's going to do one thing. So it's going to ingest an event, and it's going to emit one or more events out the other end. You can keep functions small and simple and time limit them by doing things like supporting paging. So Slack, you don't know how many messages you're going to get, but you're going to get a chunk of messages. Add a classifier like a timestamp and just invoke the same message you received. That way you can suck messages out of the source system quite easily. Now, if you're reading stuff out of Slack, you're going to read it in reverse. You get newest to oldest messages, but you want to post them into the destination oldest and newest. So again, you're going to need to store it somewhere. And on the way out, then ordering is quite important. So you want to be able to order them. So I've put Kinesis in the middle. You also want to rate limit because Slack gets really unhappy if you just start hammering it. So Kinesis, again, gives us an opportunity to guarantee that ordering, but also control how fast we're pushing stuff into the destination. So if we go back to our questions, how many messages are there in the channel? Actually, it doesn't really matter anymore, because messages are just going to get read in chunks until we're done. How long is it going to take? Again, it doesn't really matter because it's asynchronous. I'll read them in as fast as I can, and I'll push them out the other end as fast as I can. But I've got rate limiting to make sure I'm not putting the downstream systems under too much load. And what happens if one of the messages fails to send? So one of my migrate messages in the middle, it just comes garbled. Well, we've got a lot of options now. So we can just bin the target channel and replay the whole stream again if it's just a transient failure. Maybe it's actually a code failure, so I've actually got the message so I can debug it and fix the problem, then replay the stream. Or I can just simply drop it and ignore it. Oh, great. So, like I say, we develop things in a BDD style. So I want to start with, let's just jump back. Each one of my functions, I want to describe what are the inputs, what are the outputs. So that's quite a simple spec. So if I receive an event when I'm migrating a channel, if it contains a timestamp, then I should post that to Slack so I get the appropriate list of messages back. Equally, each of the different contexts, that's going to affect how the output is going to be. What's the output? Well, it should be a list of events that I'm going to ultimately send on somewhere. Using this approach, we can get a really high level of code coverage, over 90%, and it's also really quick. But then how do we change stuff together? Because it's an event-driven model now. So in order to support testing of services and making sure that they hang together, we create journeys. So I get some messages. That migrate channel service is going to emit a particular message, but then I can pass that into the next function call that I'm expecting. So it's a bit like consumer-driven testing with Pact or something like that. Those dependencies are actually desirable because if you change something in the semantics of the event, you want to know as fast as possible all the services that are going to be impacted by it. So here's a quick example. Got a bunch of messages on the left. One of the messages should end up going through a different event, and ultimately it should get posted to the destination. But how do we generate these in the first place? Well, we're going to do some integration testing, and I can capture the output of some of those integration tests and use those as an input for the test data itself. So that starts to turn it into a more approval testing approach. So how do you pass events in the system around? So Fred George at Yao, it was a Yao Nights talk on IoT and microservices. It showed a really simple pattern. So you've got a Rapids channel up at the top, so an event bus that contains all the events that you're going to receive in the system. Then you want to be able to filter those and publish those into what he calls rivers. So they're separate channels of themed events of the same type. And then down at the bottom, you've got ponds, which are your microservices, showing the behaviors that your service is going to provide. But the key thing here is your service might read from the Rapids, or it might read from the river, but everything it generates, it's going to stick back up on the top. So this makes them nice and decoupled services, which means you can create a service to generate some events before you've got anything to consume them. You can easily add in a new downstream service without impacting the upstream at all. So we implemented this with the rivers and the rapids in SNS, and it seemed to really scalable, cost-effective solution to us. We weren't too fussed about ordering, so if you're really key on ordering, then you'll need to use something like Kinesis. We did briefly play around with everything consuming stuff from the Rapids, but that quite quickly became an explosion of events and hard to filter out anything that's interesting, so the rivers really helps that. So we've got events flowing through the system. We've got an architecture of how we're going to plug our functions together, but how can we design the internals of a function itself? So this is sort of what we've come up with. So the handler, that's always going to be the entry point into your system, into the function, sorry. Its job is to unwrap any incoming events, so like I said, SNS or maybe Kinesis, do a little bit of inversion of control, then delegate down to a service layer. And then it's going to get some events back and it needs to send them out. I've got the sort of integration layer around the outside, and that provides a bunch of ports, like the port and adapters pattern from Alistair Coburn. So they provide the services and the integration to the external services, meaning that they send out or they retrieve events from a database or from Slack or something like that. But the key thing here is that those integration points, again, they're dealing in events or messages. The service in the middle is the imperative flow of your service. So that's the bit that you can write the simple BDD spec for. And that's obviously got a dependency on your integration layer. But the simple thing is, because the integration's talking messages, then it's really simple to stub out the expected messages you're going to be getting back. So you can do it in a really fast feedback kind of way. And right in the middle, we've got our core domain events and any other functional code that we need to service the details of the actual function itself. So this is sort of a mashup of things like clean architecture from Uncle Bob Martin, but there's also a great talk by Gary Bernard on functional core and imperative shell, which describes if you can use value objects or events as the key transaction or the key flows within your functions or within your system, it means that you don't really need to do very much mocking in the end. So if you look back at our tests, they're hitting the service layer, which means that we don't need integrated services, we don't need dependencies on the outside world, we can describe exactly what we're expecting on the way in, what we're expecting on the way out, and we can have a high confidence that the service itself is going to work functionally. But, sucky colours. But obviously you do need to verify that stuff is going to talk to the outside world properly. And one of the sort of challenges you hear when you start talking about microservices or serverless is that, well, if I'm actually just consuming services, aren't I just testing that I'm using, or aren't I just testing like the downstream services that I'm using? In my mind, actually, you're testing that you're using those services as you intend. But if you can abstract those integration ports and adapters into separate pieces of functionality, it means you can test them in isolation. So if your contract breaks with the service, which you have no control over, then you'll get to see it fairly quickly, and you'll get to see it in an isolated place. Local stack. So how can you test AWS services in your integration tests? So local stack, it's an open source project. It originally came out of Atlassian. I believe the guy who's there is, I think he's now left Atlassian to go full-time on local stack. But it provides a local implementation of a number of AWS APIs, and I'll give you a quick list in a little bit. So it's helped simplify our testing because it obviously makes setup and teardown super easy. And our tests run faster because we're not having to go against the cloud. Oh, actually, and going back, error injection. So if you think about something like Chaos Monkey for EC2 instances, local stack can be part of your like serverless monkey or something like that for starting to do error injection of what happens if the AWS APIs start to misbehave. And you can capture that and test that in isolation. So the code itself is written in Python, but it's available as a Docker container, so you don't really need to care. An example of starting it up, you can see all the list of services, SES, SQS, Kinesis, blah, blah, blah. They all run on a different port. So hooking it into your tests or your application is really simple, because all you need to do is those like 5 lines of code to specify where that local stack endpoint is living. As it also ships as a Docker container, it's really integrated into your container pipeline. So there's an example of our Bitbuckets pipeline on the right-hand side, which has got local stack running in it with a modicum of services. Oh, demo time, demo gods. Oh, good God. Right. So, just to show you, hopefully, how quick it is to start adding a new service in this sort of pattern, can we bring up the code? Huzzah. Right, OK. So, that's our current architecture. At the moment, we're spitting out some events, we're migrating messages, but I don't really know how many messages we're consuming at the moment. So I want to add in some stats. So a simple place to put it is when you migrate a message, that's going to generate an event. So we can listen on that and generate a count to understand how many messages are we going to get back from the system. So that'll see how many messages we're pulling in, and then later on we'll be able to check, okay, have we actually posted the right number of messages? That's an exercise for the reader. Right. Okay, so let's have a look at our spec first, because we're doing this behavior-driven. Wrong one. Oh, sorry, actually, no, let's look at the event first. Good point. So what's an event look like? So I'm going to generate some stats. What's the event that I'm going to expect? Magically. Might look something like this. So I'm going to have a channel, and I'm going to expect a number of messages in it. So already, this ties back into our journey earlier on. So the example journey that we've got has got 11 messages in it. So if this all works correctly, then I'd expect a count of 11. Let's see the test. Yep. Awesome. OK, so blah, 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 blah. Let's go down. So I'm expecting it should return a channel stats event. So my new service is going to return a channel stats event. Awesome. So when it's invoked, then I want to check that the event coming out is what's expected. Can you just jump up to the top? Oh, where we set it. Here's an example. So when it contains a lot of messages, so I've got an event, so I've got a channel migrated. I can stub out my data store, because that's just going to return a count of a lot of numbers, 440. Let's go down. And I can verify that the count that I actually get back matches the expected count. OK, let's run it. Let's test. Let's test it. Did you rename it? Is it running as... Oh, it fails. That's good. Right. Go minion. Make it work. Comment out the promise. There you go. And obviously we go around the loop test driving this, but this is a thing. Oh, give me a fist bump. Boom. Wicked. So my service is working, but I've not connected it up to anything yet. So the data store, that's going to return a count of the number of items I've got in DynamoDB. So here's an integration test I created earlier. You can see that's going to point at local stack. And if you run it, I'll show it in the doohickey. Just renaming it, so we're just running this one in isolation, because it's still a work in progress. Oh, change the timeout. just a bit of jiggery pokery. Right, so now it's going to run our integration test. Oh, it's not working because we haven't started local stack yet. So, second tab along, middle one. Middle one, yep. Boom. Talk amongst yourselves for a moment. Change the timeout back as well, whilst we're doing. Little cheat so it fails fast enough. Ignore that because that's still getting the request from earlier. Right. Yep, let's go. So now it's hitting DynamoDB, it's populating it with a bunch of results, and hopefully, demo gods. Oh, well, it didn't work because we've not implemented it yet, but I should expect that the number of messages for the given channel, 0 should equal to 50. OK, make it work. Boom. Done. OK. Back to. No, do you want me to? Just because you're building microservices, you're building serverless, you're deploying to the cloud, doesn't mean you're just going to hack stuff together. I still think you should be testing it. However, if you create a loosely coupled event-driven architecture, then it means you can iterate really quick. If you create a robust functional design, it means that you've got focused tests, which again are going to run really quick. And if you isolate your integration points and use things like local stack, it means that you can have confidence before you've even deployed it anywhere. So if you can test first and you can test local, then you're going to have a fast feedback loop and you're going to achieve serverless at speed. Thank you.